have three great speakers for you today. It's my pleasure to introduce Daniel Theobald with Mekable, Katsaros with Locus Robotics, and Florian Pestoni with in-robit. But we're really excited to have this panel here with some solutions for driving mobile robotic interoperability. With that, I'll turn it over to the speakers.
Thank you. Hey everybody, welcome. So we're excited to be here. I think landscape of mobile robotics has changed significantly over the past few years. I think we've all seen that. It's interesting that a few years ago when we started talking about interoperability, there was very little interest at all. Of course, more recently, as we started to see the explosion of these type of robots being used in the real world, people are running into the reality that robots are actually going to have to deal with robots from other companies, other equipment and that type of thing. So the Mass Robotics Interoperability Standard aims to help the industry move forward and contribute to the solution of that problem. We've got two great panelists here today with me, Florian and Patty. Florian's from InOrbit and Patty's from Locus. And they're each going to talk a little bit about their companies and what they do and some of their perspective on interoperability. Then I'm going to spend a little bit of time presenting the current state of the Mass Robotics Interoperability Standard. And then we're going to open it up for questions. All right, Florian.
Awesome, thanks Daniel. So thanks for being here. I know, as Dan was saying, this used to be a kind of somewhat esoteric topic for a very small number of people, so it's good to see a room with a lot of people here who are interested in this space. Maybe just by way of introduction about our company, InOrbit, we work both with the robot developers, companies like Locus that makes robots, and then as well as the end users, the companies that are deploying robots as part of their operations. And we work on something that we call RobOps. Think of it as DevOps for robots, if that makes any sense. Or think of it just as robot operations. What does it take to run robots at scale in the real world? And you need both sides. You need the operations teams that are out there in the front lines every day working with the robots, and you need the brilliant roboticists who make the robots in the first place, and you need data to bring it all together. So we help provide that data platform to bring these two sides into one continuous improvement loop. Now, when we talk about interoperability, as Daniel was saying, a few years ago you would have one robot, maybe a few. As you start adding more and more use cases, you start adding new vendors, you start trying to figure out how to make them all work together. This is really going to grow exponentially. I think maybe it was a simpler time when you would have like a single vendor, a single use case, maybe a handful of robots just going from point A to point B. Now most companies that are really deploying robots at scale are bringing in and mixing and matching. So that's where interoperability comes in. Now what happens if you are lacking interoperability? All of these things just don't play nice with each other, and then people end up upset and trying to assign blame. So there's a few initiatives going on in the industry right now. Obviously, we're proud members of Mass Robotics and helping contribute to that, but just to keep it real, there's multiple initiatives and they each have their strengths. So I'm getting a little bit over time. We'll talk some more about Mass Robotics. I'm not going to go into too many details right now, but for example, in Europe, the use of VDA 5050 is growing very rapidly. And it's becoming almost like an expected capability. On the other hand, in Asia, there's a few deployments of something called Open-RMF, which is an open source initiative by the same people who brought you the robot operating system, or ROS. And we at InOrbit, we play nice with all of these standards, and we're contributing open source as well to the community. Basically, just to make it easier as a robot developer to incorporate and become compliant with some of these platforms.
And I think it's just important to mention here that these are not competitive efforts, right?
Yeah.
As an industry, we need multiple standards. I mean, anywhere where there's standards, you tend to find that there's a variety of standards that help the industry work together.
And I think they each have their strength and their origin story almost. VDA started with automotive companies trying to figure out how to make all of these AGVs work together. I think Mass Robotics was more of a mobile AMR vendors, just really trying to get in front of the need. Open-RMF, really leveraging that open source community and ROS community. So they each have their value. So at a conference last year, we showed this orchestration of different robots in the real world. We had Locus, Mir, Auto robots working through multiple of these standards. So if you missed it at last year's AMR Logistics Conference, we'll have an event tomorrow at 10:30. Where we're going to, again, talk in a little bit more technical detail about the standard. We'll show robots and software from different vendors all working together.
Yeah, and the key for that event tomorrow, out in the demo area on the floor, is how to implement the interoperability standard in 5 easy steps, I guess it was. So how to mass robotics interoperability. How to implement mass robotics interoperability standard in 5 easy steps.
So if you, in addition to that, if you want to see orchestration in the real world, I invite you to come by the InOrbit booth, where we're showing different robots going end-to-end from placing an order in an e-commerce system all the way to fulfillment in real time. And with that.
Thank you. Thank you very much. That was great. Everybody hear me okay? Yep, okay, now I can hear myself amplified. My name is Katsaros, and I'm Director of Marketing Operations for Locus. I'm going to give you a little bit of information on Locus ourselves, and then really talk about how we think in terms of interoperability and the importance of it, and the importance of robots working well together. This just kind of gives a quick view of some of the form factors we have for automating and transforming warehouse and manufacturing. You can see all the platforms before I forget to say booth 4415 here. So you can see these robots in action. So just some info on the Locus difference. We really work with our customers to scale, help them scale quickly. They're easy to implement, easy to get up and running. We do robots as a service. We have minimal infrastructure requirements. So just if you think about that in terms of interoperability, it enables us to deploy and help our customers automate quickly, and then also work with the automation and the equipment that they have on the floor. And so we're very serious about that, ensuring that we're servicing the customers as best as possible, and sometimes that does involve implementing our automation solutions as well as the ones that they have currently in place or ones that they want to build in the future. So this is just a little video. So we're deployed, we have 250 facilities contracted, over 100 customers worldwide, and this just gives a little bit of a view of what you'd see in a warehouse, and a little preview. If you come by our booth 4415, you can see the bots in action, and you can interact, and you can come in. We don't have anything walled off. You can come in and you can see clearly how we work with people to help with assisted picking and to really help the workflows and help improve. So this will play for, I think, 2 minutes, but just wanted to give you a little preview show of that. So we're all playing together. Number one, choice of global brand. So as I mentioned, we're worldwide. Here are some examples of some of our customers, DHL being our largest, but work with 3PLs, retail, industrial facilities. And then this view just shows, you know, a full sort of warehouse facility, manufacturing industrial facility, just to show all the different points at which our customers are automating. And so we have various use cases and pick methodologies, and we offer that flexibility. And then that last bullet point, interface with automation, whether it's conveyance, whether it's forklifts and other robots, it's very important to us to work with the other automation and equipment that are found throughout the facility. So our customers can we can really support them end to end as they need it, as they're working to improve, to maintain their SLAs across. So that just gives a little information on us.
Cool.
Thank you.
Back to you.
Okay, so you know, I think that lays a good foundation for understanding part of the reason why Mass Robotics felt that it was important to help facilitate interoperability between robots of different vendors was really to remove friction, was to allow customers to buy robots with confidence. You know, it's always kind of scary for a customer to buy something. There's that whole lock-in issue. You know, well, is this going to be able to play nicely with this other technology that we have? And I think there was a time when people, you know, perhaps thought that, well, you know, there's just going to be one company that owns it all. Of course, that's not the way that any real industry works. There's a lot of companies working together to meet customers' wide variety of needs. So the Mass Robotics approach is to bring the industry together to have this conversation. And Mass Robotics is really dedicated to this idea of helping the industry grow worldwide and you know, providing services and support to both robotics companies, to companies buying robotics solutions, and also to really help promote the STEM education, the next generation of engineers that we all need to, you know, grow the industry and grow our businesses. So I think I kind of covered this. It's one of the things I really like when I go to Mass Robotics is just seeing all of the STEM projects they've got going. They've got this great program for young women to learn engineering, and I was going over to Mass Robotics for board meeting one day, and I went to the wrong room, and there was just this room full of people doing these really exciting projects. And the thing that really stuck with me is just how excited and happy these young people were to have the opportunity to you know, do technology. You know, a lot of these are inner city kids, and so really appreciate that work that Mass Robotics does. And of course, it's a worldwide organization where there's real focus on you know, the industry across the globe, not just in one region. So interoperability, what is it? Why do we need it? We've covered that a little bit already, but you know, the main idea is that automation is inevitable. There are going to be solutions from a wide variety of vendors in the marketplace, and more importantly, in customers' warehouses, factories, restaurants, you name it. So we need to get ahead of this. And you know, I'd like to talk about, just really quickly, introduction of myself. So Daniel Theobald was co-founder of Mass Robotics, and right now I'm focused mostly on Mekable. Mekable is an automation consulting organization to help large organizations sort of navigate their automation journey. Also a founder of Vecna Robotics, a world leader in autonomous forklifts, and doing open source agriculture farming robotics at a company called Twisted Fields. So I'd like to talk about this concept called pre-competitive collaboration. It's, I think, a good sign of a mature industry. Pre-competitive collaboration is this idea that different companies that are competitive at their core with each other in some way have a vested interest in working together in a pre-competitive context to move the industry as a whole forward. And there's this great anecdote of executive from Intel talking about how pre-competitive collaboration is really what made the fulfillment in many ways of Moore's Law possible. So Moore's Law is this idea that approximately every 18 months to 2 years, you would be able to double the number of transistors on a piece of silicon, in essence, creating an exponential growth of computing power. And the thing that he pointed out is that Moore's Law was not a law of physics, right? This isn't like gravity or anything like that, right? Moore's Law was a goal. It was a goal set by the industry as a whole. In a sense, when they adopted that concept, Moore's Law. But the only way they're able to accomplish it is by working together as an industry. There's so many common problems that they all shared, and once they got over this idea that that any one company could do it all by themselves, they started to work together on these problems. These things were getting in the way of completing, sort of the next step in Moore's Law. And as a result, we have the compute power that we have today. So I thought that was a really great example of how an industry can really, sort of set aside competitive differences at an early stage when solving problems and work together to really create a bigger pie for everybody. Because what we all want to do is remove friction. We want customers to be able to buy robots with confidence. And that's a lot of what this is all about. Just a little bit about the AMR Interoperability Standard version 1.0. So this was released a couple of years ago. And the focus was really, I would say, around keep it simple. I think where you mentioned VDA 5050, it's a great standard. It provides a lot of value. It is a very complicated standard with a lot of very specific implementation requirements for certain contexts. What we wanted to do at Mass Robotics was create something that would start a discussion and then create sort of this beneficial cycle of improvement in the industry. And what we determined was that the biggest need was sharing of basic information. Because if I have a robot driving around and all it knows is about the other robots from the same company, it can do an okay job up to a point, but as the number of robots from other companies starts to increase or the environment gets more complex, we start to get bogged down. And what you find when you're doing these planning tasks is with just a little bit more information, right? If the Vecna forklift knows where the Locus robots are, then we can start to take that into account in the planning algorithms and start to do things that optimize the use of the space for robots from a number of different vendors. So it's a very simple standard, very, very easy to implement. I think Jason was the one from Locus who basically said it took them about an afternoon to implement it. There's a lot of great tools to do it. As a matter of fact, if you are a ROS-based AMR solution, there's open source ROS tools that you can use to just download that package, and essentially you become Mass Robotics AMR interop compliant right out of the box. So there's just some basic information the robots are sharing with each other. Where am I? Where am I going? Some basics around payload and status of the robot. So the idea was to just keep it so simple that we could make it really easy for people to implement, so that there's no excuse not to. And in addition to the demo we did here last year, there have been a number of different efforts in this area to demonstrate this. There have been some grants from different government organizations to demonstrate it. And these demonstrations with a variety of robots from different vendors have actually gone very well and shown that not only is this not a hard problem to solve if you put a little bit of effort into it, but it actually provides a tremendous amount of value. One of the, I think, significant ones, which I I think is why we see products like InOrbit has coming out, is because customers want to see their whole operations on one pane of glass. And that's obviously only possible if you have information being shared in an open and digestible way. So, you know, there is an open source viewer that will allow you to you know, just basically download it and run it, and then after you attach the right listeners, you can see any robots in your facility that conform to the standard on a single pane of glass. And one of the things that people ask is, well, how do the robots all show up on the same map? Because, you know, every vendor has different maps that they use. They have different ways of mapping. So that was, I think, one of the big challenges we had to address early on. And the industry came up with an approach to that where we basically set what we call planar datums, but it's a number of physical points in the environment, at least 2, that all of the robot vendors agree on, or the customer agrees on, whoever. Here's point A, here's point B. Those are physical points in the environment. Everybody also puts those physical points in their own maps, and then basically the maps all can align and scale appropriately. What we did not want to do is create a standard that forces robot vendors to try and change the way they're doing things. You know, also because standards can get in the way of innovation, and we don't want to do that. You know, the idea again was keep it as simple as possible. Ultimately, those planar datums should be GPS coordinates in the world, which can allow you then to, you know, really cool, sort of visualize your robots on a global map to zoom in, zoom out, know where everything is. Okay, so that was version 1, and just an update. So the reception for the interop standard was very positive to the point where it has gone to an international standards organization standard that is now going through committee. The current status of that for version 1.0 of the Mass Robotics Interoperability Standard is that it's out for vote. The vote is expected to pass, and then committees will be formed, and probably first meetings will be in September. So if you are interested in getting involved in that, please let me or one of the other panelists know. The chair for that committee is Mike Behrman, a tremendously knowledgeable person, has been in the space for a long time, and certainly welcomes everyone to get involved. You know, getting involved is a way that you can make sure that as these standards develop, that they actually meet your needs. You don't have to just, you know, sort of deal with whatever the rest of the world comes up with. You can actually have an impact and make sure that things that are important to you and your companies are addressed. So right now we're working on version 2.0. Again, this is a great opportunity to get involved. The way this process is working now is that Mass Robotics has a small working group that's a lot more agile, moving a lot more quickly, and then that feeds into the International Standards Organization process for standardizing it worldwide. But in version 2.0, we're starting to look at sort of the bigger picture of how do we start to include bidirectional communication, i.e. how can robots not just share information, but how can they actually start to communicate in a way that allows planning to happen between the systems. You know, some negotiation of space, some reservation of a breezeway or a charger or those kind of things. I'm not going to spend a lot of time talking about this because I want to open up the panel to questions. But this is going on, and I have a lot of slides that go into details of that. So if you're interested, we can certainly look at those afterwards. But again, we highly encourage everybody to get involved with Mass Robotics. There's a lot of benefits to being involved. Mass Robotics has a tremendous number of resources available to help companies trying to automate, companies who are trying to provide automation solutions, investors who are looking to invest in automation, and of course, as we talked about early on, people who are just trying to learn about technology, tremendous amount of investment in STEM programs. So we will not go through these in detail, but I did want to mention just before we get into questions also We are working as well on interoperable charging, and this is an area that is still somewhat hotly debated, but there's, I think, a tremendous opportunity here, because what you see is that, it used to be when you had an electronic device, every device sort of had its own charger. I don't know if you guys remember having this experience, but I'd be trying to find, where is the charger for this thing, and where's the charger for that thing? And you can argue with the suitability of USB as a charging standard, but it's kind of just worked, and the fact that I can generally find a USB cable to plug in all of my devices is a big benefit. So for charging of robots, one of the problems we've heard from customers is that as we're deploying lots of different robots from lots of different companies, now we have to have an entire room dedicated to chargers for each one of those robot vendors. And obviously, again, that doesn't scale. So we're starting to work on this problem. I won't bore you with the details or the proposal where we're going right now. But if this is something that's important to you, please reach out to me. I'd love to get you involved with the working group. I think InOrbit, of course, must see the value in the concept of interoperability, because you're building an entire company around that. Which, of course, would beg the question, how do you see these standards as being competitive or complementary to what you're doing?
Yeah, that's a good question. We absolutely see them as complementary. I think being able to have different robots working together is what we're all aiming for. If you're here in this room, you're probably interested in that. I think there's an interesting give and take between working on a product and working on a standard. So, to be honest, our product today can do a lot more than what the standard can do. And again, if you come by the booth, you'll see it in action. Some of these ideas that Daniel was sharing about, for example, 2.0, they're already working in the real world and commercial deployments. But at the same time, if we reduce the friction, the term that you used, then more robots can join that ecosystem. And this is definitely one of those network effect type of problems, right? Where the more people have a fax machine, the more valuable each fax machine is. Some people here may not even know what a fax machine is, but it was a way to exchange data. So I think it's very much the same with what we're doing here with robotics, which is bring some of, lower the barrier for a robotics vendor who wants to participate in this. This is all voluntary, of course. If their customers are demanding it, they'll probably want to do it. So lower the barrier and then join a growing ecosystem. In our case, we actually support all three standards. We're a Mass Robotics member, we contribute to it, but just like in the example you were giving before with equipment having different chargers, Europe uses 220 volts and the US uses 110, but we can handle both.
Yeah, exactly. Well, I think that the great point there is that the value is in the orchestration of these different platforms. It is not in the custom interfaces to make them standard, right? So when your robot can show up and be ready to interact, then tools like InOrbit can really, be effective and lower cost to deploy.
And I think what I would say is, so interoperability is like a very geeky word with lots of syllables. It's really about, about the protocol for exchanging data. But that's just the foundation, right? Then what do you do once you can speak that protocol? That's orchestration. And I would say if you want to simplify it even more, I think what end users really want is it just works.
It just works, and there's pizza, pepperoni, cheese, and it's all assembled by a robot that interoperates with our